Hi, in this video we'll be talking more about kinetics. So the definition of kinetics is the rate, aka speed, at which a reaction occurs. Now there's three ways to determine the rate. First way is by using reaction rate can be determined by studying the disappearance of a reactant. So let's say we have A plus B reactants makes C plus D products. Reactants are used up during a reaction. So over time, concentration is decreasing. Now you can find that by using, this is reactants. You can find that by using rate of A is equal to negative concentration of the change of A over time. And you can do the same with rate of B because they're both reactants. It will be negative concentration of the change of B, concentration change of B over time. Over here it's not in A, it's supposed to be time. Concentration, the change in concentration can be found by doing concentration of final subtracted by the concentration of initial. Because reactants decrease over time, A final will be a smaller number than A initial, which is why the answer will be negative. Now, one thing to keep note of is that rates are always positive. So therefore, this will give you a negative answer, and to change that into a positive answer, that's why we add a negative sign in the front. So for example, we have A gas makes B gas plus C gas. And then time in seconds and concentration of A in molar. Now 0, 2, 5, 10. Now we can use rate of A is equal to negative change in concentration of A divided by time. So this will be rate of A is equal to change in concentration. We can pick any 2 points over here. Now let's say we use 0.47 minus 0.5, these two numbers, divided by the change in time, which will be 2 minus 0, which will be 2. So this will give us an answer of rate of A is equal to 0.015 molar per second. Now, if you chose two different points, like 0.35 and 0.43, using different numbers will not give you identical answers, but the answers will be close enough. Our second way is that reaction rate can be determined by studying how quickly a product appears. So as we said before, reactants before goes from a lot to none, and products go from none to a lot. So same reaction, A plus B makes C plus D. Now reactants are used up during a reaction, so over time concentration is decreasing. Again, rates are always positive, so rates will be rate of C is equal to positive. We don't need a negative sign anymore because the final will be bigger than the initial. And rate of D will be positive changing concentration of T. Again, this is because concentration of final, let's say D final, which is a bigger number, minus D initial, which will be a smaller number, will give you a positive answer. And rates are always positive, so this time we do not need to add a negative sign in front. Now our third way is reaction rate can be determined by studying how quickly the overall reaction takes place by comparing rate of reactant to the rate of product. So for example, we have A plus B, no, A makes B plus 2C. And now we can use moles from the balanced equation. For example, is to calculate the rate of formation of C if the rate of disappearance of A is 0.08 molar per second. So 0.08 molar per second is for A. Now how do we calculate for C? Well, the simplest way is for every 1 mole of A, there are 2 moles of C. So this will give an answer basically 0.08 times 2. So this will be 0.160 molar per second. And that is the rate of formation of C. Just by doing stoichiometry. Rate of formation of C. Last thing we're going to do is to find an instantaneous rate at a given time. Reactants disappear over time and products appear over time. As we reach equilibrium, the rate could change. To find that, we use the slope of the line tangent to the curve of that given time. When you use slope of line tangent to the curve at that given time. So let's say this is our curve. We need to find the instantaneous rate at this time period over here. Let's say 10 minutes. And you can find that by making a slope over here. And by finding the slope, you'll get the instantaneous rate of this line. After learning the 3 different ways to find the reaction rate, now it's time for us to solve it. And we can do this by using rate is equal to K times A, reactant A to the nth power, times reactant B to the nth power. Now in this case, rate is the rate of disappearance of reactants with molar over time. K is the rate constant. Now this constant depends on what reactants are and the temperature, what the reactants are and the temperature. M is the reaction order with respect to A. N is the reaction order with respect to B. Now what is the reaction order? Reaction order can only be found by using experiment data. And there are 3 types of reaction order. We have zero order. This means doubling the concentration has no effect on rate. And this is basically saying rate is equal to K times A to the 0th power. A to the 0th power is 1. So doubling the concentration will have no effect. Next, our first order. Whereas doubling concentration doubles the rate. And this can be used as rate equals K times concentration of A to the 1st power. Finally, we have second order, where doubling concentration quadruples the rate. And this can be used as rate is equal to K to the A times K times A to the 2nd power. And again, during this, and this is what M and N are. So if M is 2, that means it is the second order in respect to element A. Now, in order to find the overall order rate of the reaction, it is M plus N. So both of these. So if M and N both equals 1, then the overall rate of the reaction will be 2, M plus N. Okay, now that we learned how to find the rate, in the next video I'll do some examples to show you how to find the rate, as well as how to find the orders of the elements, of the reactants. Thank you for watching.